Hello. In Compact Sections 1.2, the IGES import and export features were added. So for import of IGES, the steps are first to create a new document, so you have something clean to read into, and then you select the IGES file that you want to read. And it's important to note that when you create that new document, you pick dimensions, whether it's inches or centimeters, and that's what's used in Compact Sections. The units in the IGES file are ignored. I want to talk for a minute just about what the IGES file is and how it's organized, so it's not such a big mystery. There's 5 sections. There's a start section, which just has it's a one or two lines. It just has a human readable prologue. Then a global section, which gives information about what system created this file, when it was created, who authored it. Then there's a directory section, which for each geometric object or IGES primitive, just some overall information about where to find that object in the file, in the parametric data. The parametric data is just for a circle, it would be the center point, the start point, end point. For a line, it would be the start and end point for a line. And for splines, a B-spline, it would have knots, weights, control points. And finally, the terminate section, which just has a pointer to each, has a line number for each, the start of the global, the directory, the parametric data sections. So what's imported? The objective of Compact Section is simply to create geometric objects like the outline of an I-beam. Anything that isn't related to that, an IGES file may have many unrelated things as far as Compact Sections go. So if you passed it an architectural drawing, it wouldn't care about virtually anything that's in there. It would just throw it out. So text or dimensions, things like that, it has no use for. So what it does import are lines, which are type 110s, circular arcs, which is a 100, copious data, planar curves. So that's a type 106, and then there's a form 63. There's many different types of copious data. It's only the one planar curves that are imported. Parametric splines, which are 112s. 112 is a hodgepodge of different types of splines. The only one that's imported is the cubic power series polynomial. B-splines, which is a 126. It's non-uniform rational B-splines. Everything in Compact Section is a NURB, a non-uniform rational B-spline. And finally, it must have a composite curve, which is a 102, and that's what Compact Section needs to know to assemble the various components, the lines and circular arcs, into a shape. Okay, so here we have a simple IGES file, and here's the various sections. You notice it's organized in 80 characters wide, and then in column 73 you'll have a letter to delineate which is the start, G is global, D is the directory section, P is the parametric data, and T is the terminate section. So it's the 5 sections that I just talked about. So the global section, as I said, would have who produced it, what version of IGES was used to produce it, the time it was produced. And then the directory has 2 lines for each geometric object. So a 110, as I said, was a line. There's 2 lines in the directory, and the second number here is a pointer down to the parametric data in the P section, where to find the data that goes with this particular line. And then there's the circles. So it just goes line, circle, line, circle, line, circle, line, circle. And then the 102, which I said that's the assembly instructions for how to put all of this together. And so down here for 110, start point, X, Y, Z, end point, X, Y, Z, circular arc, the center point, and the end point of that circular arc. Then the 102, which is the assembly instructions. It says there's 8 pieces, and then it gives the line numbers in the directory that it's using. So it's 1, 3, 5, 7, 9, 11, 13, 15. That's this stuff here. And so that is what tells, that's what CompactSections needs to put this thing together. So let's go read this file in. I'm going to, up here, click import, and simple IGES file that we were just looking at. And, okay, let's go back and, okay, so if we click this point here, you can see it lines up with the start point up here, 322, 348. It goes from 322, 348, and then the end point is here. So let's see if these match. So that's all there is to it. It just goes through, and this circular arc starts here and goes to here, and etc. And then the 102 puts it all together. Now in this case, this is all in the XY plane. You can pass it sections that are not in the XY plane, but there'll be a transformation matrix that I should have mentioned in the list of what it reads in, that tells you how to convert that from whatever plane it's in to the XY, so that CompactSections can make sense of it. It always works in the XY. So as long as it's a planar shape, and it has a transformation matrix, a 1, 2, 4 in there, tells you how to convert, that will tell you how to map it to the XY plane, it should read. Okay, now the export from CompactSections to a CAD system. Everything, there's only one geometric primitive that it exports, and that's a non-uniform rational B-spline, a NURB, which is a type 126. So the advantage of a non-uniform rational B-splines is it can represent every geometric primitive. It can do lines and conics and circular arcs and any spline shape. And it also outputs a 102. And it's going to be in the XY plane. So once you export it, it will come in the XY plane of your CAD system, and then it's up to you to transform it into space, into 3D, where you want it. So the export's very simple. It's just export and pick the text file, the IGES file that you want to write to. And that's all there is to that. And then I just want to take just a few minutes to talk about how this, if you wanted to do something programmatically, how that would be done. So here I've written a little code in an Excel document. And I don't want to go into too much detail on how to program in Excel. I've covered that in other videos. But let me just give a quick overview here. I'm going to go into this button and see the code. So when you click on this button, this code here will execute. We're going to write to a file called doubleibeam.iges. So if that file exists, it's going to delete it. That's all that's going on here. And then it says, call this subroutine, write read IGES. And that's this code here. So this portion here, what it's doing is it's going and looking at the current worksheet, the active sheet, and it's looping through it and looking at L.L.C objects. And if it finds one with a program ID of structuresoffice.compactsections document, then it activates it and sets this variable, which we dimension as a compact cross-section as a compact section document. I'm going to set a breakpoint because it's easier to just walk through it and see it executing. Get out of here. I'm going to click on this button. It's gone through and it's activated that L.L.C object that is the compact sections document. It's going to clear the contents. I've just used a log to create this, so some of this stuff is superfluous. I'm going to add an I-beam. And add another I-beam. Add parallelogram. Write to this IGES file in temp, doubleibeam.iges, which is the file that we looked up here to get rid of if it already existed. Okay. Okay, then we just we write it out and then we read it back in. And that's all there is to it. So thanks for listening. If you have any questions, please contact us. If you have any IGES issues, please send those documents to us and we'll read it in, get it to work. If there's a bug, we'll send you a compact section document that was read in back to you, and if it is a bug, we'll get a fix out as soon as possible. Thanks for listening.